Hello, everyone. Today's lesson is 5.1. It's Unit 4, Solving Systems of Linear Equations by Graphing. Let's get started. Okay, so this is in your book, the book that you have, from the book that I gave you at the beginning of the year. It's from chapter 5, and we are in section 1, 5-1. And the objective today, daily objective, is by the end of the lesson, you should be able to write and solve systems of linear equations by graphing. I forgot the G there. Okay. And you can solve real life problems. Okay, so let's just talk about what a system of linear equations is. A system of linear equations is a set of two or more linear equations in the same variables. An example is shown below. Y equals x plus 1, equation 1. Y equals 2x minus 7, equation 2. So together they are called a solution of a, together they are called a system of linear equations. In this class, we are mainly working with two equations working together, two equations, okay? It mentions here two or more, but we're mainly working with two equations. Now, what is a solution? A solution of a system of linear equations in two variables is an ordered pair that is a solution of each equation in the system. So the solution of a system of linear equations is the point of intersection of the graphs of the equations. An example of this in the book, they talked about two roads meeting together at an intersection. Okay, so if you had a road that going like this and another road like this, and let's say you had a monument right in the middle where the roads met. So the system of linear equations with two equations, two lines, that monument would be considered the solution of the system. So the first way of solving this is by graphing, and that's what we're covering today. So our key idea is working with graphing. Okay, so we're going to solve a system by graphing, and it's a three-step process. Three-step process. It goes fairly quickly. Step one is that you're going to graph each equation on the same plane. Okay, so we've got graphs within this lesson already embedded, and I will graph each of the equations in the same coordinate plane. Step two, we're going to estimate the point of intersection. So we're going to give a good estimation of what that intersection is. And then step three, we're going to check that point from step two by substituting for x and y in each equation of the original system. So let's take a look at example one. Example one is as follows. Solve the system by graphing. You've got equation 1 and equation 2. Now, both of these equations are already set up in slope-intercept form, so it'll be quite easy to graph. This first one, you have a slope of 2, okay, and a y-intercept of 5. Okay, so we're going to start at 5 with our first point. All right, and then we're going to apply the slope. We're going to go up 2 over 1. Up 2 over 1. Or down 2 over 1. Down 2 over 1. Okay, some of the things we've learned with graphing is the shape of the line. The shape of the line. And with the shape of the line comes the sign, the sign of the slope. Okay, so we're going to go down 2 over 1, down 2 over 1, down 2 over 1. Okay, so this is going to be our first equation 1. So I tried to do it as straight as I can. I could use a tool that's with the smartboard here, but that would be equation 1. Now I'm going to switch colors for the second equation, equation 2. So equation 2, we have a slope of -4 and an intersection point of -1. -1. Okay, so the y-intercept is here at -1. And we're going to apply the slope, -4 over 1. So we'll go up 4, 1, 2, 3, 4 over 1. Up 4, 1, 2, 3, 4 over 1. Or we could go down 4, 1, 2, 3, 4 over 1. But you can see where we have our graph. So we have the system graphed. So we graph both lines on the same coordinate plane. Now, the solution will be this intersection where the monument between on the streets, okay, if there was a monument in the middle of the intersection, okay, or like a roundabout like we have in Cold Spring. So this would be the intersection between the two equations, and that point would be -1, +3. So at -1, +3 would be the solution. And we found the solution by graphing. So what does it mean? It means that this x, -1, and this y, +3, are work for both equations. So you'd want to check it. -1 is x. So 2 times -1 is -2, plus 5 is +3. So that checks out on equation 1. And -1 times -4 is +4. Subtract 1 would be +3. It would also check out for equation 2. So this is a solution to the system, and we found the solution by graphing. Okay, we're going to go right into 3 solid examples of on your own of this. And I'm just going to go right into that. If you wanted to pause the video, you can right now and work on them. Number 1 is y equals x minus 1, y equals negative of x plus 3. Number 2 is y is equal to -5x plus 14, and y is equal to x minus 10. And number 3 is y is equal to x, and y is equal to 2x plus 1. These are excellent examples of systems and using graphing to solve. Okay, so let's start with number 1. The slope of number 1 is 1. The intercept of the first equation, y is equal to -x minus 1, is -1. So we're going to be starting out at this -1 for this one. Okay, then we're going to apply the slope of 1, up 1 over 1, up 1 over 1, up 1 and over 1. And you've got yourself a nice line that travels at a slope of 1, and it crosses at the intercept of -1. Equation number 2, y is equal to, I'll switch colors, go to that color there. The slope here is going to be -1, and the intercept is at +3. So we're going to start our graph at +3 for the intercept. Okay, you can see where that's at. And then we're going to go down 1 over 1. down 1 over 1. And you can see where we have our intersection already. Now you could continue on with finding more points, but once you have your solid intersection there, you could just extend your lines out and go to your solution. Now it appears this solution is at 2, positive 1. So our solution is at 2, comma 1 for number 1. And if you take a look at that, 2 minus 1 is 1. So it checks out for number 1, equation 1. And then if you take 2 and take the negative of that, be negative 2, add 3, you would be at positive 1. So both these equations check out with that solution. X is 2, Y is 1. Now what's nice about these first 3 on your own, they're all in slope intercept form. And that's easy for us to graph. Let's take a look at number 2. Y equals negative 5x plus 14. Okay, now 14 is going to be off our grid here. So we're going to have to maybe find some points a little bit better. Y is equal to negative 5x plus 14. Okay, so I've got a slope of negative 5. Okay, and a y-intercept of 14, okay? So up here at 14, 11, 12, 13, 14 is where the graph starts. So we're gonna go down 5, 1, 2, 3, 4, 5 over 1. Down 5, 1, 2, 3, 4, 5 over 1. Okay, and you can see how the line is forming. 1, 2, 3, 4, 5 over 1. And we have ourselves the line that goes up through these points. That's not a very good line. Let me redo that. One, 2, 3, 4, 5 over 1. So we got this point here. And we've got this point here. So this was 14, down 14, down 5, 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. So I'll extend that out like this. You know, I could use the tool that's with the smart board. Equation number 2. Let's switch colors here. Slope is 1. Intercept is negative 10. Okay, so slope is 1. Intercept is negative 10. Okay, so let's go ahead and graph this. At negative 10 is where we're going to start. 8, 9, 10, which is down here. Up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. That appears to be the intersection right there. And it looks to be 4, negative 6. 4, negative 6 is the intersection. So at 4, negative 6, we have the intersection of the two graphs. So if I put 4 in for x and I subtract 10, I have negative 6. So it checks out with the second equation here. And if I have 4 times a negative 5, I have a negative 20. Add 14, I get a negative 6. So both of them check out for number 2. Number 3, y equals x and y equals 2x plus 1. Okay, so this has a slope of 1 and an intercept at 0. Okay, basically whatever x is, y is. So you've got this proportional relationship, goes through the origin, and it heads up like this. Oops. Got a little crazy on my thing there. Okay, so. So when X is 1, Y is 1. When X is 2, Y is 2. And that would be your graph. I just did it again. That's weird. Just undo that. Okay, and it comes down and so forth. Okay, so we've got ourselves, I always say, don't make small graphs. Let's take a look at the second one. Slope is 2, intercept is at 1. Okay, so at 1, we've got our crossing there. And I'll flip to a different color just to show this off a little bit better. So at this case, we're going to go, we are going to have a positive 2 slope. So we're going to go up 2 over 1. Okay. Or we're going to go down 2 over 1. There's our intersection right there. Okay. And it appears we're at -1, -1. Okay, and you can see where y is -1, x is -1. And when if x is -1, 2 times -1 is -2, plus 1 is -1. They both check out for that example. And that would be on your own, number 3. And that's on page 204 from your book. All right, now we're going to do our last example, and then we've got 4 more on your own. So let's move to the word problem. And it is football season. And we just had a Vikings game with a bad kicker. So this is kind of goes along with those lines. A kicker on a football team scores 1 point for making an extra point. I don't know why this says has a B in there. Take that out. And 3 points for making a field goal. I think everybody knows that. The kicker makes a total of 8 extra points and field goals, okay, in a game, and scores 12 points. So we're going to write and solve a system of linear equations to find the number X of extra points and the number of Y of field goals. Okay, so let's take a look at our keywords here. A couple things. If we consider X as the extra points and Y as the field goals, it tells us right away that we have a total of 8 extra points and field goals. Okay, so this little statement right here is going to give me my first equation. X plus Y equals 8. Okay, so we were told that if you add up the total number of extra points and the total number of field goals, you have 8 of them. Okay. We are also told in this line that in the game, the kicker scores 12 points. Okay, so the way we calculate that is by taking 1 point times the X plus 3 points because of our field goals times the Y, and that's equal to 12. Okay, and that's equal to 12. Okay, these are not in point slope form. So what you can do is put them into point slope form, or find whatever way you want to graph it, using the intercepts, finding 2 points, whatever way you want to do. Okay, so I would probably just find the slope intercept of this first one. That would be Y equals the negative of X plus 8. Okay, so we're going to start out here at 8. We're going to go down 1 and over 1. So each of these would be points on that first equation. So I'll connect up those points nice and straight. So down 1 over 1. I subtracted x from both sides, and now I have it in slope-intercept form. I will probably use our intercepts. What's the x-intercept of this second equation, or the y-intercept? And it's pretty easy to see. I see this 3 and I see a 12, so that tells me 4. But x-intercept is when y is 0. If y is 0, x is 12. And if x was 0, y would be 4. Okay, if x is 0, y would be 4. So let's graph these 2 points. 12, 0, and 0, positive 4. Okay. Now, just be careful here when you're pulling this line through here, because it might be a little bit off because of this. So I might want to also consider, so my graph is only up to 10, but the graph should look like this. Of equation number 2. So what it says there, at 6, positive 2. Okay, I had to take a little glance at the book, I'll admit. 6, positive 2, we have ourselves the solution. Okay. And if you did do slope intercept here, you would have found that it's down 1 over 2, down 1 over, or is it over 4? Actually, if you subtracted x and then divide by 3, it'd be down 1 over 3 for that one. Down 1 over 3, 1, 2, 3, down 1 over 3, 1, 2, 3, and that is your intersection, 6, 2. So that means that the kicker had 6 extra points, okay, extra points. And the kicker had 2 field goals, had a big game that day. 2 field goals. And you can see that 6 and 2 work for the top equation, and 6 and 2 work for the second equation by checking. And that would be example 2. Now, to finish up the lesson today, we have 4 on your owns, 3 graphs, and 1 question relating to the kicker question. Okay, so we're going to finish up this video with those 4 questions. Let's start with, I think everyone's going to fit on those grids nice, or graphs nice. So let's start with the first one. Y equals negative 4x minus 7. So, and x plus y equals 2. This is a very straightforward one. So this has a slope of negative 4, intercept at negative 7. So at negative 7, the start of the graph, we're going to have a negative 4 slope. So 1, 2, 3, 4 over 1. 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 Okay, I accidentally hit the button there. Okay, so this is the graph for the first one. The second one is going to be x plus y equals 2. So in this case, you have y equals the negative of x plus 2. So we're going to have a slope of negative 1 and an intercept at positive 2. Positive 2. So let's go to that then. -1 is our intercept, or I take that back. Let's go back to that. It's +2 is our intercept. And we have a -1 for a slope. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1. You can see where we intersect, right where I landed on this line. So this would be the intersection point for that. And then back to my other color. And you probably have a lot better graphs if you have a chance to use specific graphs, but you can kind of see how that works out. That is the intersection point, -3, +5. -3, +5, and that would be your solution to number 4. -3, +5, and if you plug those numbers in, they do work, okay? So that would be number 4. Moving on to number 5. X minus y equals 5, and the -3x plus y equals -1. Okay. These are in standard form, so I'm going to rewrite them in slope-intercept form. Subtract the x. Well, actually, I'm going to push the y over with the 5. And I'd have x is equal to y plus 5, okay, adding y to both sides. And then if I subtracted the 5, I would have x minus 5 equals the y. So my slope is 1. My intercept is -5. Okay, let's start with the intercept at -5. And we're going to apply the slope of +1. So I'm just going to put a bunch of points in here. Up 1 over 1. Move this up a little bit now. Up 1 over 1. 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 You can kind of see how that all lines up. Positive slope lines go uphill from left to right. If you remember that from chapter 4. And that would be your first equation. Second equation, you have add 3x to both sides. You'd have y equals 3x minus 1. Your slope is 3. And your intercept is at -1. So slope intercept is your go-to. And it's going to be your go-to next year too. So -1 is your intercept. And +3 is the slope, okay? So +3, I'm going to go up 3. Okay, so I'm going to go up 3, 1, 2, 3 over 1, okay? Or I go down 3, 1, 2, 3 over 1, 1, 2, 3 over 1, and there is my intersection right there. So when you're finding the solution, you're finding that point of intersection. Okay. So you can kind of see why there's the last couple, because of the smartboard, I will hold off on drawing the lines in there yet. So you can see that intersection is going to be at -2, -7. -2, -7, and that would be your answer for number 5. Okay, so the difference between the first 3 on your own and these 3 on your own, it's the graphs are not in slope-intercept form. Okay, 2 more on your own. This next one is 1/2 x plus y equals -6. And 6x plus 2y equals 8. Okay, let's start with this first one. Okay, so I'm going to subtract a half x from both sides. So I have y equals -1/2 slope x minus 6. Okay. So we'll start out here at -6, and then we have a negative slope. So I'm going to go up 1 over 2, 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 or down 1 over 2, down 1 over 2. Now, what's important here is to get an understanding that the slope, which is negative, has a shape of the line going downhill left to right. Okay. So it's good to keep an understanding of that moving forward here. Okay. Second equation, and this is number 6. Okay, so we're almost done with the graphing. We have one little word problem left. So if I subtracted the 6x from here, I would have 2y equals -6x plus 8. Then if I divide by a 2 and divide by a 2 and divide by a 2, my equation in slope-intercept form is -3x plus 4. So I'm going to start out here at 4. That's our starting point. We have a -3 slope. So 1, 2, 3 over 1, put a stop off point. 1, 2, 3 over 1, another stop off point. 1, 2, 3 over 1, another stop off point. Okay. And you can see there at 4, hold on a second. 1, 2, 3 over 1, 1, 2, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. Okay, so our graph looks like that. Let's double back. Let's go back here. I have nobody correcting me because I'm, obviously I'm doing the video here. So I'm going to go back to this equation, -1/2 x minus 6 first. Okay, double back on this. So -6 is here. And I got a -1 over 2 slope. Okay, good enough. So then if I subtracted the 6x, have it with the 8, divide it by 2, divide it by 2, divide by 2, I would have a +4, but I have a -3 slope. 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 1, 2, 3 over 1. Okay, I'm back. I apologize for this. I have a +4 intercept, but it's a -3. So I didn't take that into account. I was drawing it with a +3 slope. So I have to go down 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1. Okay, so this line here cuts through, and this line here, the second equation, comes down and cuts through. So I made a mistake on the slope. So when I was graphing a positive slope, and I should have been graphing the negative slope. So sorry about that. But your answer will be +4, -8. +4 and a -8 for number 6. Right here. And that would be number 6. And lastly on this video is number 7. The kicker makes a total of 7 extra points and field goals and scores 17 points. So we're going back to example 2. It says, so we have our 7 extra points and field goals, x plus y equals 7, x plus 3y equals 17. 17. So it says, write and solve a system of linear equations to find the number of extra points and field goals. Okay, so if you did this work, you would come up with, let me go back to this. And I will go back and grab this guy here, copy, and paste it over here. All right, so x plus y is 7. So y equals negative of x plus 7. Let's do that first. So the first equation is y equals negative of x plus 7. So at 7, I'm here, okay? And I'm going to go down 1 over 1. Down 1 over 1. Got it right this time. Down 1 over 1. Down 1 over 1. And as you can see, I got that 1 is the slope. Second equation. So if I subtract x from both sides, I'd have 3y equals the negative of x. I'm going to be off the screen here with this 17 plus 17. If I divide by 3, divide by 3, divide by 3, I would have y equals negative 1/3 x plus 17 over 3. Okay, that's an odd number. So it's like 5 and 2/3. 5 and 2/3. Okay, so it's not the greatest greatest situation there, but let's get pretty close. Okay, so 5 and 2/3 is right up here. Okay, and we're going to go down 1 over 3. So down 1 over 3 puts you here. 1, 2, 3. It's over here. Solving by graphing. And as you can see, the intersection of 2, 5, 2, 5 would be the solution to this example. 2, 5. And that would be number 7. Okay, so this is a system. This is an introduction to a system of equations, and we solve a system of equations by a number of different ways. And the first way today is by graphing. And so keep an eye out for these types of problems in upcoming assignments. Pretty much a four-step position here. I think it's just 3. You graph each equation, estimate the point of intersection, then check. Okay. So hopefully you found this beneficial, and it's from chapter 5, section 1. And I hope you have a great day. Thank you very much for listening.